Hello, my name is Kayleen Koblos, and today I'll be presenting database analytics. For some, it may be hard to wrap our heads around what exactly defines the term database analytics. So in this presentation, I'll be going over a little review of databases, then talk about database analytics, data mining, cognitive computing, and then wrap it all up in a conclusion. Just for review, a database is a collection of data or information that is specially organized so that it can be easily accessed, managed, and updated for rapid search and retrieval by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. The information in many databases consists of natural language text or documents, number-oriented databases that primarily contain information such as statistics, tables, financial data, and raw scientific and technical data. Small databases can also be managed on personal computer systems and may be used by individuals at home. Now we're going to talk about analytic databases. An analytic database is a read-only system that stores historical data on business metrics such as sales performance and inventory levels. Business analysts, corporate executives, and other workers usually use analytical databases. They run queries and reports against an analytical database, and then also information is updated on a regular basis to incorporate recent transaction data from an organization's operational systems. An analytic database is specifically designed to support business intelligence, BI, and analytic applications, typically as part of a data warehouse or data mart. The 5 main types of analytic databases are the following: columnar, data warehouse, in-memory, MPP, and OLAP. Columnar database is organized by columns rather than rows. In result, this reduces the large bulk of data elements that are usually read by the database while processing queries. Data warehouse appliances combine databases and hardwares and BI tools in an integrated platform that's tuned for analytical workloads and designed to be easy to install and operate. In-memory databases load the source data into system memory in a compressed, non-relational format in an attempt to streamline the work involved in processing queries. Massively parallel processing, or MPP databases, spread data across a number of servers, enabling the systems to share to query processing workloads. Finally, online analytical processing, or OLAP databases, store multidimensional cubes of aggregated data for analyzing information based on multiple data attributes. Now let's talk about data mining. Data mining is the process of sorting through data to identify patterns and establish relationships. Data mining is primarily used today by companies with a stronger consumer focus, such as retail, financial, communication, and marketing organizations. It enables these companies to determine relationships among internal factors, such as price, product, positioning, or staff skills, and external factors, such as economic indicators, competition, and consumer demographics. It also enables them to determine the impact on sales, consumer satisfaction, and corporate profits. Finally, it enables them to drill down into summary information to view detailed transactional data. Next, we are going to talk about data mining parameters. The first one is association. Association is looking for patterns where one event is connected to another. Sequence or path analysis is looking for patterns where one event leads to another later event. Classification is looking for new or old patterns in hopes to organize the data better. Clustering is finding and visually documenting groups of data not previously known. And forecasting is discovering patterns in data that can lead to reasonable predictions about the future. Now we're going to talk about cognitive computing. Cognitive computing is a simulation of human thought processes in a computerized model. It involves self-learning systems that use data mining, pattern recognition, and natural language processing to mimic the way the human brain works. The goal of cognitive computing is to create automated IT systems that are capable of solving problems without requiring human assistance. Cognitive computing systems use machine learning algorithms. Such systems continually acquire knowledge from the data fed into them by mining data for information. The system refines the way they look for patterns and as well as the way they process data to become capable of anticipating new problems and modeling possible solutions. Cognitive computing is used in numerous artificial intelligence, or AI, applications, including expert systems, natural language programming, neural networks, robotics, and virtual reality. The term cognitive computing is also closely associated with IBM's cognitive computer system, which is shown in that picture, Watson. As I said before, a database is a collection of data or information that is specially organized so that it can be easily accessed, managed, and updated for rapid search and retrieval by a computer. The information in many databases consists of natural language text or documents, number-oriented databases that primarily contain information such as statistics, tables, financial data, and raw scientific and technical data. I also talked about how an analytical database is a read-only system that stores historical data on business metrics such as sales performance and inventory levels. Data mining is a process of sorting through data to identify patterns and establish relationships. Finally, cognitive computing is the simulation of human thought processes in a computerized model. It is important to stay up to date on databases and its parameters because of the future possibilities it can offer to businesses. Thank you.